Good evening, everyone. Welcome to the Azure Cleveland User Group. My name is Sam Nasser. A little bit about the group. We meet every second Wednesday. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure, infrastructure as a service, platform as a service, or software as a service. You can find all the meeting information for past and future meetings on meetup.com at the link listed below at the bottom of the slide. Some general information before we get started. First and foremost, please keep in mind participation is encouraged. And like I always say, the only stupid question is the one not being asked. So always feel free to jump in with a question. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And like to keep it casual but organized, so jump in with any comments or questions. But at the same time, we want to give our presenter some time to go through the slides and the demos as well. And this presentation is being recorded and will be posted on YouTube within a few days after it's being edited. So for tonight's presentation, we have Douglas Starnes, and he's going to be presenting on serverless APIs. Doug is a tech author, Microsoft MVP in developer technologies, and he joins us from Memphis, Tennessee. He's also the co-director of the Memphis Python User Group, and he is a conference speaker and organizer for a variety of different conferences. And he's also been a user group speaker for 70+ feature presentations and workshops. Doug has a Bachelor's of Music degree and has found his way into the software development world, and we're glad to have him tonight. And so with that, I will turn it over to Doug, and let me go ahead and make you presenter.
All right, thanks a lot, Sam. Thanks a lot for inviting me to speak to the group. This talk's a variation of a talk that I have done for Python, and that I'm going to do for JavaScript at at Connect Tech in November. And it's a survey talk. It's about all the different APIs and services and such that Azure provides for serverless. Not all of them, because there's so many of them here, as you'll see here in just a minute. But at any rate, I am Douglas Starnes. Powered by AltNet is my Twitter handle. There we go. Sam already went through the points that I have on what I call the obligatory narcissism slide. So I'll just go ahead and get started with basically a definition of serverless. So when this thing called the cloud was introduced, people started saying, the cloud is great because you only pay for what you need and it's going to reduce your costs. You're not going to have to go out and buy a whole bunch of servers that if you're a retailer, that you're only going to use once a year on Black Friday or something like that. And this is true. However, it's not that you only pay for what you need. You actually only pay for what you ask for. And, kind of a canonical example, if you go into Azure and you provision a virtual machine and you say, okay, I want, two CPUs, 8 gigs of memory, then Microsoft is going to charge you indefinitely until you tell them otherwise for 2 virtual CPUs and 8 gigs of RAM, even if you're only using a single virtual CPU and 4 gigs of RAM. So in other words, that's why I say you pay for what you ask for, not necessarily what you need. And of course, you can scale this up and down, but again, like I said, it's not necessarily that you pay only for what you need or only for what you use. Now that doesn't mean that the cloud is not a good thing. The cloud is still good, and it still does reduce our costs. However, serverless takes this in a different direction. Serverless bills you only for what you actually use. So when I remember, I don't know if anybody got caught up in this when Azure was first released back, what would this be, around about 2010, I guess. I don't remember exactly when it was first released, and everybody wanted to try out Azure, and so there were only a few services available at the time, and everybody went out and did Hello World, and deployed it to the cloud, and then they clicked on the link to see it, and they see Hello World, and they say, oh, that's great, because at the time Azure was in its very new stages, and it left left a lot to be desired in some places. But so people saw, okay, hello world, okay, this works. And then the instructions for hello world didn't say that you had to shut down all the resources, that you had to deprovision the resources. And people ended up getting, and they just left it running, and people ended up getting at the end of the month $100 bill for a hello world application. Now if that was serverless, that wouldn't have happened. You only when you clicked on it that once would, unless somebody else did, but your bill would have been significantly less. Now the name serverless is kind of a misnomer. You still have to host it somewhere, and it still has to be hosted on Microsoft's hardware, and they're going to expect to be compensated for that. We'll talk about that in a minute, but it's more or less, you don't have to provision servers as opposed to actually saying, hey, I want a server. So there are a number of products, and this is just a partial list here of them. I'm not going to go through all of these tonight. I'm going to try to get through these 4, not in that order. But so you have anywhere from compute products such as functions and the app service and container apps, Kubernetes service. You have machine learning services such as the bot service and the cognitive services. And machine learning, you have data stores such as Cosmos DB and the SQL database, and then you have other products such as this logic apps, which it's this interesting kind of, if you've ever used something like Power Automate or even Azure Machine Learning Studio or something like that, where you graphically define a flow of actions. That's kind of what logic apps is. But however, all of these run in this serverless, or can run in this Kubernetes, things like app service and Kubernetes service, and even actually functions in Cosmos DB can run provisioned or serverless, but they all have a serverless component to them. Okay, so let's start off here, and the first one I'm going to talk about is Azure Functions. Now, the idea behind Azure Functions is that you're not going to deploy an entire application. You're going to deploy just a single task, a single piece of code, a function. A function in software development is this idea that we have this unit of code that has a very narrow focus, and it's going to execute and just meet that single task. Now, it's not literally just a function. You can actually have in a single function app, so to speak. You can have multiple functions, but you're looking at executing, instead of executing the app as a whole, executing each of these functions and being charged only for when you execute those functions. So you're looking at that level of that fine a grain. So then again, like I was saying before, you're billed only when the function runs, not when it is provisioned. It doesn't cost you anything in the serverless, or at least costs you very little in the serverless product to provision the function. And if your function doesn't run very much, then you're not going to be paying a whole lot. You might think this is great for microservices. So you've got all these little functions out here that do different things, and then you orchestrate them together to create an app to do something useful in some way. So this isn't really about creating it. We'll see creating an Azure function here. We'll get to the demo in a minute. But what does a function support? Well, first of all, you can create it on 2 different operating systems. You can create it on Windows, as you might expect, since this is a Microsoft product, or Linux. Keep in mind that more than half the virtual machines running on Azure, I think it's 60% was the last I heard, but more than half are running Linux. So Linux is very well supported on Azure. Most of the products that I use on Azure are Linux based. Multiple languages. There are some languages that are officially supported, and some languages that and then really, to be totally honest, it'd be very difficult for any of the mainstream languages probably to not be used, although some of it you have to roll your own. So obviously .NET, C#, and F#. The documentation speaks of specifically supporting F#. I've never seen any templates, actually, any tooling for it. Somebody's probably created it. Like I said, I'm a Python guy who does some C#. So, but however, C# and F# for .NET, Node.js both JavaScript and TypeScript are supported. Python. Now, Python is Linux only. All the ones I'm going to talk about here, all these that I'm going to list here are going to be Windows or Linux, except for Python, which is Linux only. And even though Python does run very well on Windows now, it still runs it still runs much better on Linux. In fact, when I do the demos, I'm going to be using Visual Studio Code on Windows, but it's actually going to be a Windows subsystem for Linux. So I use, like I said, I use Linux everywhere. Java, for those of you who are still in Java, I don't know what something like Kotlin or a JVM language how it would support. I've actually never tried to run. I've actually only tried to do these first three here. .NET, JavaScript, and Python are the only three that I've ever really worked with. But Java is supported. This is an interesting one, PowerShell Core. Now, I actually have tried this. I did Hello World, and I guess maybe and I don't really use PowerShell that much. I'm trying. I really like the Azure command. I really like the PowerShell. What do they call it? The commandlets, I think it is, for Azure. I started working with those some, but you can actually create an Azure function in PowerShell, but again, it's PowerShell Core only. And then you can also do something called a custom handler. Now, I've never tried to do this, but I probably need to now. But if you want to use something like Go or Rust or Dart or Swift, what you can do is you can really any language that you want. If you want to write a handler for it and upload that to Azure, then you can actually write a function in many, many different languages. How can you, so the tooling, so the command line. So there's the Azure command line interface that allows you to do almost virtually anything. Almost anything that you can do inside of the portal, which you can actually create them, of course, inside of the portal as well. I actually find the command line to be a little bit easier to use instead of the portal. Of course, then again, I work on Linux a lot, so I'm used to typing. The portal, it's so hard. It's hard for me to focus inside of the portal sometimes. But we'll see the portal some tonight because you can actually edit Azure functions inside of the portal if you're running on Windows. So since only Windows is supported and Python doesn't run on Windows, you can't edit Python functions in the portal, but you can edit other languages. IDEs that you can use Visual Studio. There's support for .NET and C# only. That's both on Windows and also Visual Studio for Mac, and then Visual Studio Code, which I'm going to use tonight, which supports all of the languages. All these that you see above. All right, so you have to have a way to call a function, and there's not going to be any main program or anything that's going to call the function. So you have to have some kind of action that invokes the function, and that's going to be a trigger. And there are a number of different triggers. This is just a partial list, but for example, and when you're working or if you're building an API or whatever, most of the time what you're going to do is you're going to want to run in because of an HTTP request. So what you'll have is you'll have an endpoint or URL. You'll hit that endpoint with some kind of a client application, and then that will trigger the function. You can also run on the time. You can also use a timer function that runs on a schedule. It's kind of like a cron job. Cosmos DB, run on document change. We'll see that this evening as well. And then also other ones such as queue storage. If you add an item to a queue or a blob to the blob storage. If you get a new event from an IoT hub instance or new event on the event grid. And there are others. So Twilio, SendGrid, Azure SQL Database. There's a whole bunch of them. There's a whole table of these that we can look at if you're so interested. Then also you have to have a way to get data into and out of a function. And these are called bindings. So these connect, like it says, connects a resource to a function, input and output binding. So you could say, hey, when this function is triggered by an HTTP request, pull something, pull a document out of Cosmos DB and then send an event to the event grid or something like that. Now, not all services can be triggers, inputs and outputs. For example, HTTP cannot be input, table storage can't be a trigger, and so on. But this does allow you to mix, but you can mix and match these so that you can get some interesting scenarios out of them. So for example, you can say, okay, when there's a new event on the event grid, that's going to trigger a function, and that function will retrieve a document from Cosmos DB, and then and then when everything's finished, what it'll do is based on the results, it'll send an email with SendGrid. And you could also going to see a number of examples tonight of triggering a function with an HTTP request, retrieve a record from table storage, and then you can also just an HTTP response is considered the output from is considered an output binding, or a message get a message from the queue storage, retrieve a blob, and then use that to modify a document in Cosmos DB. Like I said, you can just mix and match these, and we'll see how different languages tonight configure these bindings and triggers. Pricing, like I said before, this is, Microsoft does expect to be compensated for letting you use their hardware, but this can be so. In fact, I've heard of people who've said they were running virtual machines or app servers, PaaS type of things for a website before, and they switched to they were paying like a couple $100 a month. There was a conference, don't quote me, I want to say it was CodeStock who told me this, but said that they moved to a serverless model, and all of a sudden they're paying less than $10 a month. And for a conference, somebody who's a nonprofit like that, so that's a big win. But there are 3 service levels, so called hosting plans. So you're going to create, and we'll go through this here in a minute, but you'll go through and you'll create an app plan, and you'll create you'll choose a hosting option. The first one is consumption. Now this is the serverless plan that you pay only for the resources that are used. So if your function's not running, you don't pay anything with the consumption plan. There's also a premium plan. This gives you several advantages. So first of all, if your functions don't run for a while, they may have to start from a cold state, and it could take a little while the first time for them to start up. Whereas with premium, you can have pre-warmed workers that will allow you to start from get you a faster startup time. Now, of course, you're going to pay for when those workers are running, but and then also you do use CPU and memory with functions on the consumption plan. I don't remember what. I think you're limited to 1.5 gigabytes of memory for running a function, but you have, I think, for some reason I want to say premium goes all the way up to 14 gigs, but don't quote me on that. We can look it up if you're interested. Also, longer execution times. I think 5 to 10 minutes is the limit for serverless, and I forget what it is for premium. I really only have ever used functions really in with serverless. And then also you can deploy them inside of Docker containers, only on Linux. Then you can also have this dedicated plan, which basically runs inside of an app service instance, and then your standard app service charges a supply. So let's take a look at an example of how this consumption pricing, what this might look like. So,
Doug, if I can interrupt you for a second.
Certainly.
If you could go back to the previous slide for just a moment.
Yeah.
So looking at the premium, you had mentioned that it has pre-warmed workers. Mm-hmm. How long after the last usage of a function will those pre-warmed workers shut down? Meaning, how long until they go cold?
To tell you the truth, I don't know. That's actually a good question we can look into. There's different ways. There's a lot with the premium. So I'll say this: with consumption, everything is pretty much auto-scaled for you, and all of the rules about how this stuff works are predetermined. With the premium, you have a lot more flexibility, so you can specify. So there's different. So you can tweak a lot of the settings with the premium. So that may be one of the settings that you can tweak. But and of course, the longer that you want the workers to stay warmed up, of course, the more it's going to cost. I think I looked, and I think I went to the pricing calculator and I did just the default, and I think it said it was going to cost for a premium instance, it was going to cost something like $300 a month. But like I said, there's a lot of these settings that you can tweak.
But it still revolves around usage as opposed to just having a provisioned space for it, correct?
Yes, yes, yeah, yes, but there's going to but with consumption where the minimum that you're going to pay is basically zero.
Hmm.
With premium, there is going to be a minimum cost even if it's not running,
Yeah,
even if
right,
your
of
functions aren't
course.
running. Yeah, because you have to have though because you've got these all this these three down here aren't really going to cost you anything if you're not if your functions aren't running. This one here is still going to cost you something even if your function is running. It is not running.
Gotcha. Thank you.
Okay. Sure. Okay, so let's take a look at. And I'm only going to run through the consumption model because, of course, now we're talking about serverless. But the benefit of this is that you get better performance, but you still don't have to deploy an app. You still get to use that functions model. So basically here, the way that they build this is what is it? So that would be $0.00016 per gigabyte second. So what the heck is this thing called a gigabyte second? This is this new unit of measurement that the tech industry has dreamed up for us. And this is not something that's specific to Microsoft. AWS, Google Cloud, they also use the same metric. But what this is, it's the amount of compute resources that would be used to run a function for 1 second with 1 gig of memory. So if you run a function for 1 second and it consumes 1 gig of memory, that is considered to be a gigabyte second. And basically the way that your build is execution is you take how many gigabyte seconds did your function use. You take the execution time, and that's billed by the second. Many of the ones that I'm showing tonight, because they're demos, they're very, very simple, so they're very, very quick, and they generally run in about 200 to 300 milliseconds. But you're still going to be paid for a second, and that's times the memory multiply that times the memory consumed. So for an example, if you have a function that executes for 10 seconds, uses a half a gig of memory, that's going to be 5 gigabyte seconds. And that would be about, what would it be? Probably about 8/100ths of a second is what you would be billed. Of course, you're looking at executing these things millions of times. So, that I always say in the cloud, I've said, in the cloud, milliseconds matter. And because you're doing things many, many, many times. You're also billed for executions. 20 cents per 1 million executions. And executions is every time the function is invoked. But this is really cool, is you actually get 400,000 gigabyte seconds and 1 million executions per month for free, just for being you, just for showing up. And anybody can get that, and that is, if I'm not mistaken, that is part of their free. That's part of the Azure Free Forever tier. So you can actually run a serverless application, and depending on how much you optimize it, you can actually run a pretty decent application for free forever. So let's take a look at some functions here. So let me pull up my browser, and I'll hop into the portal here. Okay, so I've got a resource group set up here for the demos tonight. And what I'm going to do is go over to create a resource, and I want to create a function app. Functions live inside of a function app, and the function app is where you're going to say, okay, here's what the hosting plan that I want to use, here's the language I want to use, here's the operating system I want to use, and so on. So I've got my resource group here that I've already created, and I want to give this a name. So let's see here. I've got my notes here so that I don't get confused. So CS func app DAS. Okay, so I'm gonna run this from code. Select a stack. I'm gonna start off with the .NET. It's got the latest LTS versions. Select a region. I'm running everything in East US. And then here, my operating system, I'm going to select Windows because I'm going to do this first one inside of the portal. And then the plan, which I can have, so here's my consumption, which again is serverless, the premium functions, which are pre-warmed, and the app service plan that runs inside of an app service instance. And then I believe that it will automatically, yep, okay, good. In case we want to look at the logs. Now this won't take, I'm not going to do this for every single one of them, but I just want to go through and show you the process show you the options for creating a function app. This should not take that long though, and Azure's probably going to be in a bad mood tonight though. But generally, it doesn't take that long. And there are some parts like when we get to Cosmos DB and a container app environment that I've done ahead of time, because creating a Cosmos DB account can take 3 to 5 minutes, and you probably don't want to watch me sit here and look at the screen. Okay, this generally takes about 60 seconds. I think for the maps. Yeah, Yogesh. Yeah, that basically that's kind of a rewording, I think, of what I said. It's you're going to pay for something that is provisioned. So that's going to be like those pre-warmed workers. That's what you would be paying for 24/7 until you tell Microsoft otherwise. But as far as like I said, there's a lot of knobs that you can tweak inside of the premium plan that may influence what's provisioned. Okay, so it's complete. Nothing really. Oh yeah, go over here. Lots of different things. This is why I talk about the portal is information overload. But if you go over here to functions and you tell it to create one, I have several different options here. You can develop in a portal, develop in Visual Studio Code. And actually, what I said earlier, I said that as far as tooling, you had the CLI, you had the portal, you had Visual Studio and Visual Studio Code. You can use the command line in a terminal, and you could use Vim or Atom or Sublime. Is Sublime Text still a thing? You can use really anything that you want to. Azure is very tool agnostic in many ways. But I'll just go ahead and choose this and develop in the portal. The templates. So here are all the different triggers. So the HTTP timer that we saw, many different ones here. Go ahead and hit the HTTP trigger. You want to give it a name. So CS portal function, and then these func. C's not working, and then the authorization level, and this basically decides how do you grant access, who can run this function. There's 3 different levels. Admin, which is going to require a master key that gives you access to all of the toys. Function, which is a key that allows you to just run the single function, and then anonymous, which basically makes it a public API. And for tonight, I'll go ahead and do that. It's path of least resistance. You can also do user-based authorization. It's a little more involved. There's some it's the setting over here in the portal to do that. But create this, and successfully created. Now, if I go over here to code and test, I'll see this code here in the this is the boilerplate function. Now, I'm not going to labor over this because I've got a more involved example that we'll look at in a minute. One thing to notice here is that the file extension here, CSX. Remember a project called C# script is where I believe this comes. Is a guy named, he works for Google now, but this is back in the early days of C#. He created this project called C# script. His name was Nikhil, and I don't remember his last name. But anyway, and now so this is not necessarily. But even though it's not a full-blown C# file or whatever you might think, or a full-blown app, you can still bring in, and we'll see this here in the more involved example. You can still bring in almost anything that's .NET. For example, here we're bringing in the Newtonsoft namespace. But all this does is it simply simply this function right here. And what's going to happen is when it's invoked, and I'll show. There are several different ways to invoke it that we can look at here. It's going to look at if it's a GET request. It's going to get a name parameter out of the query string, and if it's a post, it's going to look in the body. It's assuming that body is going to be JSON, so it's going to deserialize it. Then it'll pick whichever one exists. If one of them does exist, then it will print out a personalized message. Otherwise, it'll ask you to pass a name through the query string of the request body. So with this in mind, what you can do, you can go over here to test run, decide what method you want to use. For the query string, you can add a parameter, say name as your get. We'll use it in a minute. Run, and then that's now the function's been invoked, and you can see over here that you can see over here in the logs that it was executed. And if you go over here to the post and the body, again, it's assuming that it's JSON. If we change this to Azure Post, run it, we're going to see Azure Post, and we'll again see we'll see the logs over here. So, and this may seem kind of trivial. I've actually used functions. So, for example, there's an event we ran one year. It's actually the first year that everything went virtual, and we ended up using Teams for the event. And we had like 6 or 7 different Teams meetings going on at one time. And this was before Teams was and in some ways Teams still isn't designed to do this, but this was when Teams was really not designed to do. We were really pushing the limits of what Teams could do, and we were thinking, okay, what happens if one of the streams crashes, or somebody, the monitor accidentally kills one of the streams? There's no way to get it back. We have to start a new one, and or at least at the time we did. That you may be able to now. Okay, thought I heard a noise. Anyway. And we're thinking, we would have to start a new Teams meeting, and then we would have to tell everybody who was in there how to get back into it. Well, instead, what we did is we just created a whole bunch of little functions, a whole bunch of Azure functions, one for each stream, and it simply redirected to a URL for a Teams meeting. So if one of them went down, all we had to do was just simply change the link to the Teams meeting that it redirected into. It was a simple function. It was like 3 lines of code. We literally created them inside of the portal. Never touched Visual Studio Code. So this actually does have a use. At the same time, they do have a URL. So if I copy this here, and if I go into something such as, I thought I had it on my, something such as Postman. I thought I had that open. Oh, come on. This is not right. Oh, well, okay, it's going to be bright, but at any rate, notice that now if I had the function level authorization, there would be a key tacked onto a really ugly key tacked onto the end of this. But if I well, that's what happens when you don't include the name. But if I were to go in here and say name equals, I'll say Postman, so we'll know that it's inside of Postman, then it will say hello to Postman. So this is so in other words, every time. And then also you should be seeing down here when I be seeing down here that it would that these logs will update as well. All right, so that's creating a function inside of the portal. You can also do this from inside of Visual Studio Code. Oops, no, I don't want to. Hold on. I don't know what happened there. But okay. All right, so Visual Studio Code. Again, I'm running inside of a WSL instance, so things are going to look a little bit different from if you were running if you were accessing local resources. But basically, what I've got is, as far as extensions go, in Visual Studio Code, if you're not using it, I mean, if you're a Wintel.net developer, use Visual Studio by all means. I'm not putting Visual Studio down. Visual Studio does what it was intended to do very well. But if you're working across platforms or you're working across languages, then you should definitely be looking at Visual Studio Code. In fact, I said I'm a Python person earlier. Let me see here if I can get this. 4 of the top 5, actually 5 of the top 6, but really the top 3 and 4 of the top 5 extensions for Visual Studio Code are Python based. You actually have to get down here to about number 13 before you get to anything .NET based. But still, so I've got a bunch of Azure, a bunch of extensions in here installed for Azure, and one of them does access Azure Functions. This is actually part of a pack of extensions that you can get. And again, and all of this stuff for Visual Studio Code is free. So if I look up here at my resources and twirl this down, and then my function app, you'll see, if I refresh, come on, there we go. There's that function app that I just created. And there's nothing in right now, and then in here is that function that I created inside of the portal. Now we're going to replace that here in a minute, and the way that I'm going to do that is by creating a function inside of Visual Studio Code. And that's the other thing, when you create the function in the portal, it's automatically deployed. So if I hit Control-Shift-P to bring up the command palette and create function, like this. Says it's going to want to, says I need to have a new project. I need to select a directory for that project. Already got one created. That is kind of the annoying thing about WSL. If anybody knows how to do this, let me know. But you cannot create a folder at the time of creating the project in WSL. You can do it in Windows, you can do it in Mac OS, but it's in WSL for some reason you can't. And then let's see here, CSVS code func. That's the one I wanted to use. And this is just a blank folder for right now. So again, it'll ask you many of the same questions. For example, it'll ask you for a language again, C#, ask me for a runtime, because right now it doesn't know where it's going to be deployed to. It'll ask me for a trigger. I'll select HTTP again. I'll call this what do I have in my notes? CSVS code func. And then it'll ask me for a namespace, and then again it'll ask me for the authorization level. Keep using anonymous, and then I'll open in the current window. This will take just a few seconds, much quicker, I think. There we go. Okay. All right, and this is the exact. Well, it's not the exact same code. It's a little bit different. I have to run a .NET restore real quick to get rid of the squigglies. Okay. So, but it's still similar. It does the exact same thing. Now, one of the additions here is this HTTP trigger attribute in this function name attribute. And this will, by default, it will influence it'll influence the endpoint. So, for example, here we're saying that we want to accept get and post requests. Since it's not specifying a route right now, it'll use the function name by default as a route, and it'll also prefix the route with API. But right now, I could actually I can hit F5 and run this. That's interesting. What? Come on. It's making a liar out of me. Well, that's not nice. Hang on. F5. There we go. Select the debugger. What step did I skip because I'm rushing through this so quickly? Okay. Okay. Apparently I skipped. The joys of live coding. You always skip a step and you have no idea what it was, because that should have worked. I skipped a step somewhere in my notes. Okay. At any rate, that's how you create a C# function in Visual Studio Code. I've got one here that's already created though, so that does something that's a little more interesting. So I'll go over here and I'll open that folder up that already has one. Source, so is it CS CryptoFunk, I believe is what it is. Yeah. Now, if this doesn't work, there's something wrong. I can even shut down this instance. Okay. This one I've got is doing something a little bit different. So I've recently in the past year I've really gotten into crypto, and there's this service called CoinGecko, and actually I guess I could show you where I'm getting this from. You go to CoinGecko, and this has also become my new standard demo. The workshop I did in Louisville a couple of weeks ago, I used this for my demo. The Pluralsight course I'm working on right now uses this for the demo. But it's really nice because there's this free API that they have that get this Swagger interface here, but that you can use to get real-time cryptocurrency information, and it's completely free. Or there's a free tier of it. There's a free tier, you make about 50 calls a minute, but for a demo, that's great. So I've got this one here, simple price. It'll get the price of a cryptocurrency. We click try it out and give it an ID. Say I want to get the price of Bitcoin in US dollars, and then execute. It'll give me the result, but it'll also give me the URL that I need to call get that information. And then if I just paste that into a browser, it'll make a GET request. So again, I don't have to have an API key or anything to do this. So that's what I'm using there. And then this back to my Visual Studio Code. Here we go. So what I'm doing here is I'm just making a call here using just the HTTP client to get the JSON back, parsing it, getting the data out that I want, and then returning that from the function. Now notice one thing that I am doing here is inside of that HTTP trigger attribute. This route keyword allows me to specify a different route instead of putting everything in the query string like the previous example did. So if I run this one, there we go. That's what I expect. I don't know why I must have skipped a step somewhere. And I'm not interested in the developer CLI right now. Then what will happen is it'll say, okay, it's got a function named getCoinPrice, and this is going to be the URL for it. So if I copy this, actually I don't have to copy this because there's this other really great extension. Let me show you here real quick called RESTbook, and that should be installed. That is weird. Okay, anyway, I don't know if anybody's ever worked with Jupyter Notebook or whatever, or something like that in for something like data science or machine learning. It's really big in the Python community. However, they don't have a picture of it here, but we'll instead see. I already had it installed. That's weird. At any rate, this is what RESTbook is. It's basically a Jupyter notebook for making HTTP calls. And what I've got here is each of these things, these cells here, I can put a command for a specific HTTP request in here. So for example, what I'm going to do here is I'm going to say get this address, get my local host for getCoinPrice/Bitcoin/USD, which will retrieve the price of Bitcoin in United States dollars. And if I run that, then it will make that request, which is going to again execute that function, as you can see there, and then it pulls back, and this is the actual price right now. And I could change that and say, Ethereum in Australian dollars, and I'll get that result. The nice thing about these Jupyter notebooks is, let's say I want to get Bitcoin in what JPY is, Japanese yen. I don't have to create another notebook. I don't have to create another complete request. I can just modify one, or I can copy these. And the other nice thing is I can distribute this with the function. So somebody who cloned this from GitHub or something, they would be able to run this function locally, and if they have the RESTbook extension installed, they would be able to start off automatically. So it's like kind of like interactive textbook, if you want to say, or interactive documentation. So it's a tool that I use quite a bit. So at any rate, that's working. One other thing that I've done here is, like I said, the routing in now this is for .NET. This route keyword in the HTTP trigger attribute, but also by default, what it will do is it will prefix all of the yes. That's right, and again that's totally free. So Sam just put the link to the RESTbook extension in the chat. But there's also this host.json file, and by default, this extensions key isn't in here. But if you add this extensions key with the HTTP route prefix and set it to blank, it will remove that. API. Otherwise, it would have API in front of everything. But that's something I generally like to do also, to just clean up the URLs. Okay. So how would we deploy this? Well, there are a number of ways that you can deploy it. You can deploy it via the command line, via the CLI. You could deploy it. You could do CI/CD with GitHub. You could do automation with GitHub Actions. By the way, if you're interested in GitHub Actions, come to my Python user group on Monday night. It's hybrid. We'll be at the Microsoft office here in Memphis, but the Microsoft office has fantastic audio video equipment, and so we can broadcast via Teams. But Mickey Gousset, who actually lives about 2 hours south of me here, he lives in Tupelo, about 2 hours south. He's going to come up to the office, but Mickey actually works for GitHub, and he's going to do a presentation on GitHub Actions. And even though it's the Python user group, GitHub Actions are actually language agnostic. So a lot of what he'll have to say is going to be relevant to is going to be relevant to many different languages and pretty much everybody. So at any rate, let's see. So another way that you could deploy this is from Visual Studio Code. So if I go over here to my Azure Blade and I go to my resources and my function app, and why does it not want to? Oh, I saw it just a few minutes ago. Come on. There we go. I have no idea why. However, if I right click and tell it to deploy to function app, and it'll say, of course, it'll override anything that's already there. This could take just a few seconds, gives me a chance to get a drink of water. I don't know why that didn't work. Okay, so now if I go over here and tell it to open in the portal, I want to open in the portal, yes. Then I should be able to go over here and get the URL for it. Right here. Here's the URL. So now I should be able to go back into RESTbook, create a new code cell, say get, and then prefix this. They hadn't had time to start it yet. Come on. Hang on just a second here. One of the joys of live coding. Take a look at something here real quick. Well, how about this? We'll let this. I'll save this URL, and we will let this warm up. I'll save that. We'll go ahead and look at another one real quick, because I don't want to waste time. Okay, so I'll go ahead and I'll kill this one. But that's basically how simple it is to get up and running. Let's look at one in a little bit different in a different language. So let's take a look at one in Python, because there are some differences between, like I said, between the languages. So I will. I'm not going to. Actually, I'm not going to create. No, I'm not going to create this one. I'll just open this one up. Got it already made. Called PyCryptoFunk. Now with Python, of course, there are different. There are different things about the language. So, for example, you'll have everything in a virtual environment, and when you create if I were to create a function from scratch, it would ask me, what version of Python do you want to have? Your virtual environment using? And then also I would be able to, in the requirements.txt, I'm going to use requests, which is a Python library a Python package rather, for making HTTP requests. And so that way, when it runs when it runs it locally or deploys it to Azure, it will automatically install that. It'll pip install that package. I've also got here, so it puts everything in a module in the underinit.py. What I'm doing here is getting the coin ID and currency again out of the route parameters, but I have to do that a little bit differently in Python. There's a function.json method or file, and that's where what you did is where you did your trigger, and later on we'll see the bindings with attributes in C#. With Python, and also you see with JavaScript, does it in this file here. So what we've got is we've got this HTTP trigger binding here. It's in, and it only supports the get method. And then here's the route. This is where I would define my route. And then here's my output binding, which is going to be again HTTP here. We'll see again example of a little bit different one later. And then also, so what this will expect me to provide a coin ID and a currency inside of the route. Then also inside of the host.json file, again, that extension for removing the route prefix. So what I'll do is I'll hit F5 to run this one. And notice it activated the virtual environment. And then I've got a REST book over here open as well for this one. There's the outputs. And then run one of these. Again, this one worked. And it works it works the exact same way, but now we're using Python. So let me see if this one will deploy. See if this one will be more. Here's my Azure Blade. Okay, deploy to function app. Yes. And it doesn't matter, even the different languages, you could still deploy them the same way: CLI, GitHub, Visual Studio Code, Visual Studio. Except with Visual Studio, you're only going to be able to do .NET. It's generally, this is the first time I'm deploying to this app. But still, okay, nope, it's going to work. Okay, so let's see here. If we browse to the website, yes. Okay, so I want to get that URL, do a get here. There we go. Okay, I don't know what was wrong with that other one, but remember Visual Studio Code didn't want to see it, so I may have skipped a step when I was paying more attention to what I was saying than I was doing on screen. But at any rate, that's how easy it is to deploy one. Now, granted, if you're working on a team or something, you're probably going to want to do something that's a little more involved. But this is the path, the path of least resistance. But anyway, that's how quick and simple it is to actually create a function and upload it or deploy it. Let's go ahead and look at one more here. Let's say this one here that I've got up now is JavaScript, and it also has the the function.json file is inside of the module. So it's got the function.json file. Again, this is just like with Python. This is where you specify your bindings, your triggers, and then the host is where you can get rid of that route prefix. The code itself, again, it does the exact same thing, except this time we're having to bring in Axios, which is a node library for making HTTP requests, which I used npm install Axios to install, and then so if I F5 this one, it'll run same URL. And if I go over here, I've got a REST book for this one. And again, everything, whoops, don't run an empty cell. Everything still works. Okay. So as you can see, truly cross-language. It is in cross tooling. It's not, like I said, it's tool agnostic. You saw how you could create one inside of the portal. And you can also, like I said, use the CLI and other tools as well. Okay, let me see if I can go back to the slides without messing anything up. All right. Okay, already saw all that. Okay, so Cosmos DB. If you're not familiar with Cosmos DB, it's this interesting data store from Microsoft, and started off life as, or its predecessor rather, I guess you could say, was Document DB, and basically patterned somewhat after a document data store similar to MongoDB. But then later on, they saw that they could do more with it. Microsoft said we can do more with this, and so introduced Cosmos DB, which supports this Document DB API, which is now more like I guess a MongoDB API. But it supports it supports multiple programming interfaces. So it's got the core one, which they call the SQL interface, although it's technically not relational. It's just got a SQL-like query language that you can use to query it. It's also got it also supports the MongoDB API. So that's the document oriented interface. This is actually how I use it the most. I actually use it most as a substitute for MongoDB. Cassandra, which is a column-oriented data store, Gremlin, which is for graphs, and then finally a table API, which is key value data store, which has some similarities to the table store service from Azure. Now, the only thing is that only the core API right now can be used. Like I said earlier, Cosmos DB rather can be used as a Azure Functions binding. Only the core API can be used as a binding, so you can use it as a trigger for a document change, and then you can also use it for input and output. Now that doesn't mean that you can't use the other APIs inside of a function. So for example, like I said, with Python, I like to use this with Python as a substitute for MongoDB. So there's a package called PyMongo, and I could definitely use PyMongo inside of an Azure function to access MongoDB on Cosmos DB or MongoDB anywhere. Or I could use it to access PostgreSQL using SQL Alchemy. But I'm just saying that it has to be that only the core API can be used as an Azure function. All right, take a real quick look at the pricing. This one also has two different pricing models, I guess you could say. You have the provision throughput, which is again the kind of like, hey, which is the you pay for what you ask for. So it has these things called request units. And this is what they say. This is just an abstraction of all the compute resources that are required to make Cosmos DB do its thing. And so, for example, what they say is retrieve one request unit would be if you're retrieving a 1 kilobyte item by its ID. Whatever compute resources are required to do that is going to be one request unit. And you can auto scale. This can auto scale, kind of similar to the Azure Functions Azure Functions Premium tier, or you can do it manually. But like I said, you're always billed for what you request. As opposed, and then because there's always a minimum amount of RUs that you're required to use. So if you're doing the auto scale, you're required to have at least 1,000 RUs, and that's RUs per second. So in other words, in a second you could retrieve 1,000 kilobyte sized items by ID, and in 100 RU increments. Or what you can do is you can again use the serverless model, and there is no minimum RU there. It's you just pay for the RUs that you use. Again, serverless. And in this one, what it is you pay for 1 million RUs, so 1/4 for every million RUs that you consume. You're also billed for storage, but like with the functions, there is a free tier. Get 1,000 RUs per second throughput and 25 gigabyte storage just for showing up. But that is the provision throughput plan. There is no free serverless tier right now, but it doesn't matter because you can actually mix the serverless functions with the provision throughput Cosmos DB, which is what we're going to see here. All right, so let's take a look at the next example. And I'm running a little bit long, so I'm going to skip to the let's skip to the version of this that's already done right here. So this is actually an HTTP trigger. I was going to go through and do an example of a Cosmos DB trigger, but it's not very interesting. It's basically an echo. So this one here, many times with cryptocurrency, what you would want to do is you would want to manage a portfolio. So let's take a look actually inside of the portal before I do that. Go back to my resource group and take a look at. So this is one of the parts that I did have to stand up ahead of time, because when you create, what you have to do is you have to create a Cosmos DB account. That can take, like I said, that can take about 3 to 5 minutes. After that, you can look inside of the Data Explorer. And Data Explorer is basically a UI for looking at the data inside of the inside of the database. So here I've got my database. Inside of the database, you have containers / collections. I see those two terms used rather interchangeably. I've got two here. This one actually, the function is not going to touch, but for the example that I'm not going to do, this is required because it keeps track of changes. It's change tracking, basically, this leases collection, and so that way it would be able to tell when a document had changed and when it should trigger the function. But we're not going to use that one because we're not going to do that demo. Portfolio, on the other hand, I've got a whole bunch of items in here, and the items are essentially documents, and they are in JSON format. So this part right here is what I provided. So I provided an ID and a username, and I provided a list, or in JSON terms, an array of more objects. And these are the different investments, which would just be a coin ID and the quantity of that coin owned. I've got several of them in here. Okay. Back over in the function itself, what I've got is I've got this first function here is it will get a particular one of those items by its ID. So I've got a route here for portfolio, and then a parameter, route parameter of ID that will be passed in. Then that's my trigger. That's my trigger attribute there. That's my trigger binding. Then for my input binding, what's going to happen is it's going to say, okay, I've got this Cosmos DB attribute, and it's going to say the database name that I want to use is this Cleveland AZUGDB. The collection name that I want to use is portfolio, and then there's a connection string that I've got over here in this JSON file. It's hidden for security reasons, although I'll delete all this stuff when I'm done. But if you look back over in your Cosmos DB, you'll see, if you go into your keys, that you've got these this connection string here that you could, and that's all that this is that connection string, and then the ID and partition key that you're going to use, that you're going to get from the route, and that's going to be put into an object called portfolio, or a class rather called portfolio, that I've defined down here. And a portfolio is merely, it mimics the structure that we saw, or that mimics the structure of the JSON that we saw. So it's got an ID, a username, and then an investments, which is a list of investments, and then each investment has a coin ID and a quantity. So we can actually work with objects. So we can work with the objects instead of so we can work with the objects instead of the JSON. Then this one down here. So all this is going to do is going to go through. This just goes through each of the investments and comes up with some JSON for them and spits that back out. Then this one down here will do something similar. It actually this one down and this one up here only responds to GET. So this one down here responds to POST, same URL, but instead, and it's going to again pull that same portfolio out. But this time, what it's going to do is it's going to look in the body for some JSON that has a coin ID and a quantity, and what it will do is it will create a new investment out of that, and then add it to the current investment, the current investments. So then what will happen is Azure Cosmos DB will automatically save that. It'll automatically persist that for me. And then what I'm doing is I'm just taking the new investment, serializing that as JSON, and returning it. Okay. So let's go ahead and F5 this real quick and see how that works. And I've got a REST book already. No, I don't want to. You can see that this one has the two functions. It has the one for get investments and the one for new investment. And if I go to my REST book that I have and clear the outputs. Okay, so first of all, if I want to get, let's look over here real quick at the Data Explorer again. And look at item number 1. And you see that John Doe has Bitcoin and Ethereum. If I go back over to my REST book and hit this, then we'll see that we come back with Bitcoin and Ethereum. Now, if I try to add Filecoin, this is a post request that'll add Filecoin, 100 of them, and it comes back with that's the new investment. And if we look over here and I refresh this, you'll see it's been added into Cosmos DB, and now if I hit that same portfolio again, it'll come back. The Filecoin now shows up. And just like with the others, I killed the route prefix in the host.json file. Okay. So that's binding. So that's using bindings with Cosmos DB to work with Cosmos DB in with bindings. But notice, but at the same time, you still could have used just like you could have used the SDK for .NET or something. You don't have to use the bindings, but I think it does make it a little bit simpler. Okay. And also something I didn't also show you because I didn't create a new plan. I'm actually running that is running serverlessly, but it doesn't matter because you can't tell because it all works the same, whether it's serverless or provision throughput. Okay, let's go back to the slides real quick because don't want to wear out my welcome. Let's look at Azure Container Apps real quick. We've been looking at running a function, just a unit of code serverlessly. You could also run a container, and that's what Azure Container Apps does. Now, also you might have seen remember from the first slide or one of the first slides, that Azure Kubernetes service, you can run that in a container in a serverless way as well. I've never done it because you have to use Kubernetes to do it, but it is possible to. But this is not Kubernetes. This is something a little bit different. Let's see what's different. Dynamic scale, so it makes scaling much more easier. So it's great. So again, it's great for microservices. Integrates with Azure Container Registry. You've got to have some place to have these containers. We'll see how to do all of this stuff here in a minute. And like I said earlier, it's Kubernetes style applications without Kubernetes. So you get a lot of the benefits of the containerized applications, but you don't have the complexity or the cost of Kubernetes, because let's take a look at the pricing. Now in this case, you are actually billed for idle apps. You are billed a very, very small amount for idle applications. And you're also billed not only for memory, but you're also billed for CPU. So there's two metrics that you're used to be billed for. Now an active app, this is the price per CPU second. So to run a CPU for 1 second costs you this much, and then for memory, it's using gigabytes per second again. For idle apps, it's the same amount for all resources. You're billed for the number of requests you use, 40 cents per 2 million. This also has a free quota, so you get 180,000 virtual CPU seconds and 360,000 gigabyte seconds and 2 million requests for free. And that would bring us to a demo. Now I've got a demo already. Stop this here. I've got one more demo over here. Well, two more actually. So here, crypto prices. And this is a little web API. And this web API does the same thing that we've seen so far. It just goes out to CoinGecko. Where is it? There it is. It goes out to CoinGecko and using a coin ID and currency brings back a price. Okay. Now what I can do is I can very easily inside of Visual Studio Code add a Docker file to it. It's going to ask me my stack and my operating system. It's going to ask me what port do I want the container to listen on. I'll go ahead with 5000. I don't need to use Docker Compose in this case. It says it already exists. Oh, okay, override them. And it creates this Docker file for me. I can now go over. I can build this image inside of Visual Studio Code. I could also build it inside of Azure. I find, however, for smaller ones, it actually takes less time to build it inside of Visual Studio Code. And now if I go over here to my Docker tab, you see that I have that, I have that container. I'm not going to run it locally because I'm already at an hour and a half. But what I'll do instead is I will push this to a container registry that oh no, hang on, it's right. Push it to a container registry that I have right here. So I'll push this to an Azure container registry. I could create a new one if I needed to, but okay. So Azure Cognitive Services. This one is kind of not necessarily your traditional serverless offering. It's more an API that they charge you for, but still, it's something that you only pay for what you use, and you don't have to provision a server. Now, it is worth mentioning that Azure Cognitive Services, you can actually get dedicated instances of some of these, but basically this is machine learning as a service. And what happens is Microsoft, they have trained really, really large machine learning models on common tasks such as facial detection or sentiment analysis or something like that. So, well, here's some of the examples: sentiment analysis or facial recognition, anomaly detection, text to speech. And they've trained, like I said, they've trained a model on, and there's about 2 dozen of these. And they've exposed these models as REST APIs. And the nice thing about this is you don't have to have any kind of experience or even knowledge about machine learning. If you can call a REST API, then you can make an intelligent app. Pricing for this, basically you're billed by request or per number of requests. The different services, there's no common rate. It depends on the service, and also they have different units. So, for example, sentiment analysis. This is we'll look at this here in just a second. This is taking a piece of text and saying, hey, is this a positive sentiment, negative sentiment, or negative sentiment or neutral sentiment? And every 1,000 text records that you process is $1. Or facial recognition. So every time you tell it, hey, I want you to detect faces in this images, you do that 1,000 times for 65 cents. Anomaly detection, text to speech, 1 million characters, $16. Notice some of these say starting. So like sentiment analysis, the more that you use it, the rate decreases. Again, you only pay for what you use. You don't pay for what you ask for. And there's free tiers for many of these services. Okay, so let's take a look real quick at a Python example for this. Don't know why that didn't work. Okay, let's open up this one. Source, PySentiment. So this is another example in Python. Basically, there are SDKs for the cognitive services for many different languages. So there's Python, .NET, JavaScript, Java, many different languages. And you can also, it's a REST API. You can just take something like request or the HTTP client or Axios and just make raw HTTP requests at them. If you look in, what you have to do is you have to provision these inside of the where's my portal? Here we go. You have to provision these inside of the portal. So I've got an instance of this one right here, the language services, which is where the sentiment analysis comes from. And then what will happen is they'll give you a key, which is basically a password and an endpoint. I've stored those over here in this auth module, and I'm bringing them in. Create a client. And then I'm going to create some text that I want to analyze. So each one of these strings, they're considering it to be a document. All you have to do is take your client, call analyze sentiment, pass it your documents, and it'll give you the results in JSON, or if you're working with the SDK, it'll give it back to you in an object native to that language. So in here, I'm going to get back 3 results, and I'm going to print out the text for each of them, the overall sentiment, which will be positive, neutral, or negative, and then it's going to give me a confidence score for each one. So if I activate my virtual environment, and then Python main. Okay, we can see here that this first sentence, Microsoft Azure is the best cloud service for everybody. That's overall positive. And it's fairly confident that it's positive. It's 98% positive, 98% confident that it's positive, 2% confident that that's neutral. On the other hand, if you say Amazon Web Services is hard to use and way overpriced, that's my opinion. That's a pretty negative statement. Ambivalent about Google Cloud. Google Cloud has some interesting services. Dialogflow, BigQuery are pretty cool. But overall, I'd rather use Azure. That one's neutral overall, as you can see here, 71% confident that it's neutral, but it thinks it also might be a little bit negative. So, and like I said, there are, if you want to do facial recognition, text to speech, there's a really cool form recognizer service as well, and they're all, if you're using an SDK, they're all going to be fairly simple to use like this. Let me real quickly go through couple of summaries, and then I'll be quiet here. All right. So like one of the things that I want to emphasize, and this is one of the things that I am trying to emphasize more now when I'm talking about Azure, is that there's really there's very low barrier to entry if you want to learn Azure. So and it costs literally nothing to get started with what I've been talking about tonight. So Azure functions, as you've seen, they can be tested locally, but there is the free tier once you deploy them. Same thing with Cosmos DB. I didn't look at it. I didn't show it tonight, but there is actually a local emulator that you can install. I think I'm not sure if it's Windows only or not, but I've been running it on Windows. And the nice thing about it is that interface that you saw where it had the Data Explorer in the portal, that's replicated by the emulator. So you still get that same interface whether you're working with the emulator or you're working online. And also, of course, there's the free tier for Cosmos DB. Again, it's not the serverless free tier. It's provisioned throughput, but it still is free. And you can, of course, again, mix and match the serverless functions with the provisioned Cosmos DB. Azure Container Apps. Actually, once you run the container locally, you're actually most of the way there. Because after that, all you have to do is upload it to Azure, and then there's a free tier as well. And then with the cognitive services, there are free tiers for most of those that have a monthly quota that you can use to experiment with them. At any rate, you can always get a $200 if you don't have an Azure account yet, you can get a $200 credit for your first month. After that's followed up by 12 months of popular services for free. There's some VMs, some databases in there, and then there's the always free tier. Of which there is an offering in each of these. So technically, you could run applications on free, and they're not just hello world. You can do actually useful things on Azure for free forever. So and that is actually not the correct. That should be en.us. I thought I corrected that, but at any rate, that should be en.us. Okay, so what did we look at tonight? So looked at Azure Functions for running small tasks in the cloud, and these are triggered by events, and then you also use bindings to get data into for input and output into the functions. Azure Cosmos DB, NoSQL data store, has multiple APIs, but if you want to use and the core API can be trigger or an output binding. Azure Container Apps. This allows you to run a container serverless. Basically, again, Kubernetes-style applications without Kubernetes. And then the cognitive services, machine learning as a service. And nice thing about that, outside of being serverless and paying only for what you use, you don't have to have any machine learning knowledge. Just call a REST API. So that is what I've got. My apologies for all of the errors, but that's all I've got, and I went about an hour and a half. So
I think that hour and a half is a testament to the length and breadth of the serverless APIs available in Azure, which is quite a bit.
Oh yeah, and this isn't in the four that I covered. That's just four of them. I had the list that was at least twice as long, and even that list wasn't exhaustive up at the beginning. So, and this is so one of the things that I haven't gotten a chance to look into yet that I want to look at, and I need to put you over here at the screen so I'm not facing away from the camera. One of the things I haven't gotten a chance to look at is the Azure serverless. I mean the SQL serverless, the Azure SQL database serverless. That's one that I'm really interested in as well.
Yeah, it's that Azure as a whole just keeps getting bigger and bigger, more robust, and very interesting products that keep getting added on. Cognitive services are one of my big favorites.
Yes, whenever I do my Azure machine learning talk, I always tell people that 90% of the time you should go to Azure. You should go to. Oh, I actually need to stop sharing my screen here. How do I stop doing that? There we go. I always say that 90% of the time you should you'll be able to use Azure Cognitive Services. 90% of the remaining time you'll be able to use automated machine learning. 90% of the remaining time, and it comes down to like 1/10 of 1% of the time that you're actually going to have to write custom code to train a model. Because that's what everybody sees the talk and they're like, okay, we're going to see code, and I'm like, if you're looking for code, you're probably going to be disappointed because it's really a very low code talk. You're muted.
I was saying it's pretty bare bones. Basically, just call an API and you're off and running.
Yeah. Well, I mean, yeah, it's there's very little to it. You don't have to know it's you toss your data at the API, you toss your data at the endpoint. Microsoft does some machine learning magic with it, charges you a little bit of money, and sends you the results back. If you're doing the raw HTTP request, that's going to come back in JSON. I think they may support XML. I don't know, but I've only done it with JSON. And but if you're working with the SDKs, which is normally how I do it, then it's gonna have structures already built in for you to use.
Yeah.
But yeah, you could use the cognitive services with literally anything that supports HTTP.
Mm-hmm. Very good. Well, thank you, Doug. That was very informative. I know it's, like I said, Azure is a very big product offering, and even though you touched on a lot of them, each one you could end up doing an entire presentation on. So,
you could do an entire presentation just on one of the cognitive services.
Yeah.
It's like I said, it's a survey, is what it is.
Yeah. No, but thank you for taking the time and appreciate it. It was very informative.
All right. Well, thank you very much for having me.
Thank you. Before we adjourn for the night.
Is somebody saying something?
I think Rajan was saying thank you. Go ahead, Rajan.
Okay. Thank you, Rajan. Thank you for sticking around.
Yeah.
Just have a couple wrap-up announcements. First of all, let me put all the links into chat that we'll be going through in just a second. And then let me go ahead and share my screen as well. All right. So thanks again to Doug for a great presentation. What I posted in the chat are links for the recording that will be posted on YouTube. Strongly suggest that you subscribe to the channel so you can get the upload notifications once the video is made available. Also, we'll be covering some tech events in just a little bit, and those will be posted on my blog. And lastly, the feedback eval form, and that's available at the link listed there, which is also in the chat window. Regarding technical events, on September 15th, which is tomorrow, the Great Lakes User Group.net, and they're going to be having a presentation on code reviews. On September 21st is the kickoff of the .NET Study Group. That is an effort that I've been hosting for several years, off and on in various iterations. So we're kicking it off again on September 21st. And the intent of that is to gather people and to be able to study Azure as a whole, specifically with a target of passing the AZ900 exam. So whether you're interested in getting certified or not, it's a great way of learning Azure from a bird's eye view. We're also going to get into more nitty-gritty. It's not just going to be a one-time presentation. The September 21st is a kickoff presentation, and then we're going to be meeting every week for the next 6 weeks, every Wednesday evening, to be able to hash out a specific topic in Azure. It's free of charge, open to everyone, so feel free to invite colleagues and friends. And the link for that is on meetup.com, and that will be posted on my blog in just a little bit. On September 22nd, which is next Thursday, is going to be the Cleveland C# VB.NET User Group, and the link for that is posted there. On September 17th, which is a Saturday, is the monthly Azure Data Platform. And that is a data platform user group that's going to be hosted in Bangladesh. And it's going to cover a variety of different topics related to Azure, and more specifically, the Azure Data Platform. I personally will be speaking at that conference as well, and along with a variety of other speakers. The meetings or that specific event is free of charge, so feel free to attend. And then last but certainly not least, November 8th through the 11th is Tech Bash, happening in Pennsylvania, and the link for that is techbash.com. It's going to be in person, and tickets are still available, so feel free to check them out. We always like to discuss job openings, And Tech Systems always has job openings available at techsystems.com/IT-jobs. In addition, if you're hiring or if you're looking for work, please feel free to reach out to me and I will make my contact information available in just a second. Speaking of which, my email, snasser@nistechnologies.com. You can also find me on Twitter @SamNasser, and my blog where I post various technical articles as well as technical events, samnasser.blogspot.com. And lastly, I invite you to connect with me on LinkedIn. And so with that, if there's no questions or comments, I thank you all for attending, and thanks again to Doug for presenting, and wish you all a good night.